So just to review some of the things we did in class about finding different trig values with the sum and difference identities, let's just look at a couple examples. So the sum and difference identities, which we have on our sheet, they are all the ones that are down here, right here, where we have sum of angle identities and difference identities. You can find the trig value of any two angles added together or subtracted using these formulas. So if I look at my unit circle, I want to usually find angles that add or subtract to my given angle. So in this case, I have 105. So pretty simply, we should know that 45 and 60 equal 105. So the sine of 105 is the same as sine of 45 and 60. So if we consider these two angles A and B, we remember that we have this identity. So if I pull this up, I'm just going to write exactly what I see for the sine of two angles added together. So it says the sine of A plus B equals the sine of A, the cosine of B, plus the cosine of A times the sine of B. Well, good news is that I know what A and B are. A and B, A is 45 and B is 60, or vice versa, it doesn't honestly matter. So sine of 105 is going to equal sine of 45, because that's my angle A, times the cosine of 60, plus the cosine of 45 times the sine of 60. And so to find my exact value for my trig function, all I have to do is find those values, which can be done on the unit circle. So if I want the sine of 45 and the cosine of 45, recall that on the unit circle, 45 is here, the x-coordinate is cosine and the y-coordinate is sine. So this is going to be square root of 2 over 2. This is going to be square root of 2 over 2. And then for 60, which is my other angle, we're going to use this point. Now again, the x value is the cosine, so the x value of this point is 1/2. And the y value is the sine, that's square root of 3 over 2. And so you'll use a lot of these numbers over and over again, so it shouldn't be too crazy. So if I multiply these, I'll get square root of 2 over 4 plus square root of 6 over 4. Just multiplying tops and bottoms. So if I add over the common denominator, I'll get square root of 2 plus square root of 6 all over 4. So that is the exact value of sine of 105, just using our basic unit circle angles. So the second example says cosine of negative 75. So when you have a negative angle, obviously we're going to have to find bigger angles that subtract to give me 75. So instead of doing two angles added, we'll do two angles that are subtracted. Doesn't have to be, but generally that is the easiest way to go. So I'm thinking of two angles that would subtract to give me negative 75, and the ones I think of, probably the easiest ones, this would just be cosine of 45 minus 120. Doesn't have to be, it can be anything you want, but these seem like the easiest. So this is my A and B. So if I look at my identity, we have cosine of A minus B, which if I use the identity is cosine A, cosine B, plus sine A, sine B. Okay. Now it is a different sign. If you look at our identities here, we're using this guy right here. So that's why I use the one with the different sign. It's just given to you in the formula. It's all just about using these formulas. Okay. So in this case, since my A is 45 and my B is 120, the cosine of negative 75 is going to be cosine of 45, cosine of 120, plus sine of 45 times the sine of 120. And again, all these are numbers from our unit circle. Now 45 we just did, so that's not going to change. That's going to be radical 2 over 2. Sine and cosine are both square root of 2 over 2. Now for 120, here are our values. So the x-coordinate is negative 1/2, so that's meaning the cosine is negative 1/2. And the sine is the y-coordinate, which is positive radical 3 over 2. So if we multiply, we'll get negative square root of 2 over 4 plus the square root of 6 over 4. So basically the same thing I got before, except for one of them is negative. And you will find most of these problems will have the same values, just with different signs. So this is just a little introduction to how we can use these identities. We will actually use them quite a bit more next time.